this is going to wrap us around a lot of the concepts we've been playing with. Now, we haven't learned everything about everything in this class. This has been an introduction, so there's a lot of holes that you need to fill in by playing. You need to fill in by coding, and you're going to get filled in a little bit through the next classes by new assignments you're being asked to work on, new things you're being asked to take on. So what I'm looking at right now is where we left off on phase 4. If you remember phase 4, we created this pizza order over here, and we have this number of pepperoni, and so we're going to come back to that here in a second based off of our modeling. And so the other things you've been asked to do is right here, I left this as the base, but you were asked to put something like a method out here. And we just made it static, string for get string input. So you, in theory, should have this already in your application. You can copy and paste it over if you're working in a new space, or you can type it in new. But for now, I'm not putting the validation side of here. We know right here that we have this J option pane, that message dialog. So I just copied that with the Control C. I'm just pasting that with the Control V, and I'm replacing the name message, which is the very specific message that we created before, with the general message from the parameter here, prompt. So whatever the user sends in, I'm going to do that, and I'm just going to return that value here. Because remember, every method has to have a return value when it states it's returning something. So in our code then, we had a method such as this that will go off and do that. And so everywhere we see J option pane show input dialog, we replace that with get string input. I can copy this and I can paste that to every place we were getting information beforehand. Now, what we did last week was created this pizza order, and you have your own product, whatever type of product you came up with, and whatever type of product that you chose to use for your application, whatever your customized business is selling. So again, I'm going to go back to Paint. And so we had our box here, and we had our pizza order. And pizza order was a nice class, but there's many different types of pizza, or DER, there you go. There's many different types of pizza orders we could have. So one of them was a pizza order with, as we said, pepperoni. But not everybody loves pepperoni. Some people like sausage, some people like veggies, some people like, anchovies, whatever they prefer on their pizza. And so what we can do in inheritance, and we've seen this in a little bit of the other coding, is we can create subclasses for the different types of pizza orders. And so for your application, maybe you have something else, like maybe you're selling bicycles. And so you have general bicycles, but you have subclasses of bicycles. So you have mountain bicycles and unicycles and tandem bicycles and different types of bicycles you might sell. And so you're being asked to come up with 3 of these, and my spacing is off on 3 of these. And it doesn't really matter what they are. So for our case, we're going to say we have, I'll use this so you can see it. We have a pepperoni pizza, and we could have a veggie pizza, and we could have an anchovy pizza, something like that. Now, there's many different ways we can model this. One of the ways you could do is just have a general pizza and have an attribute or several attributes that says what topping goes on it. Maybe you can only have up to 5 toppings, and you have 5 topping spots, and maybe they can be empty. That could be the case, and that could be a good way to model this. In our case, I have specific functionality around being a pepperoni pizza, where the total price, is based off of the number of pepperonis you've chosen to put on that. And because of that specific behavior, that makes this modeling appropriate. Because there's going to be a common behavior, a total price, that's going to vary based off of the type of pizza you chose. So one could be anchovies, pepperonis, the number of pepperonis on there, and so we count that up. Maybe anchovies is the based off of the type of anchovies that are chosen. Are they from Eastern Europe, or are they from Asia, or from whatever? So there could be some behavior based off of the market price of anchovies based off the chosen place. So that's the idea of the design of what we're going to get at. And then we're going to be able to go off and build one of these based off of what the user chose. So we're going to have to do this in a couple different stages. But that means our pizza order object has to be modified and also expanded. So we're going to create a new class for a pepperoni pizza, just like we drew in our picture here. All right, and then we'll create another new class for, we'll just say, our anchovy pizza. All right, and then we'll make one more new class for our world famous veggie pizza. All right, and so in inheritance, we want to all these tie into a pizza order. And so we want to have the pizzas extends with the S. You can see how it went dark, bold and purple when I did extends, because I typed in the keyword appropriately. Pizza order. All right, so I type that in, I save it, and then all of a sudden my class is extending it out, just like we talked about in inheritance. And so I can copy this, and I can go to my pepperoni pizza, and I can do the same thing. Extends pizza order, Control S saves that. And anchovy pizza, I click over on that one, and then paste that in, Control S saves that. And so for our pizza order then, there's certain things that are going to be the same. The customer's going to have a name, they're going to have a returning type, they're going to have a type of cheese. What's not going to happen is not everybody's going to have the number of pepperoni, right? And so we can take that out. And then we can go over to pepperoni pizza, and we can add that back in over here, number of pepperoni, which is going to break our pizza order for a minute because the total isn't going to work, right? So we can take advantage of this notion of polymorphism and just leave the total here be return 5. So maybe it's $5 for a base pizza. But we can copy all of this behavior, and we can bring it down to pepperoni pizza and paste the whole thing inside of here, and then go back to the pizza order and take out the number of pepperonis. So if you order just a generic pizza, maybe it just comes as a basic cheese pizza, it's $5. And then, as we said before, if you order a pepperoni pizza, it's the $5 plus the number of pepperonis times 10 cents a pepperoni. So that gets our special type of pizza inside of there. Now there's other things, the number of pepperonis, I got to take them out here from the getters and setters as well, because that's something that doesn't apply. All right, so there's our basic pizza order. Now, what I'm choosing in this case not to create an abstract class. That's something you'll take on in a future class. You'll be able to take on inheritance, understand this notion of abstract classes, and play with it more. So I just want to mention the fact that I'm choosing not to do that, and there's nothing wrong with that. I can have a basic pizza order that allows you to get a cheese pizza and gives you the cheese type inside of there, and then customizes that cheese pizza into a pepperoni pizza with the number of pepperonis on it. So let's do one more just to get into the habit of that. So anchovy pizzas, I can say private string region of fish. All right, and then from that I can also add the total method. Now I want to show you something a little different in the tool. In the first case for pepperoni pizza, you can see I copied and pasted this over from pizza order. So I know I think I'm overwriting and using polymorphism of this because I copied and pasted, and I think it's exactly the same. The other way you can do this is you can right click here, and you can go to insert code, and you can do Alt-Shift-S at the same time. So you can see the key Alt-Shift-S, and then you can say from here override/implement a method. And in this case, you can see I have all the methods I had up above. I want to override total here. I want to change the behavior of total from being just the $5. All right, and so when I do that, I get this @ override sign. where this is what's called a meta tag, and this tells me that I'm intending to override. So if I spelled total wrong, like did totals or something like that, then it's going to give me a compiler error at this point because I am not overwriting that anymore. You can see I can create a totals up above, which I don't want to do, or I can remove the override annotation, which I also don't want to do because I was intending to do it. So the best answer is for me just to spell it correctly and just say total, and then that'll work. All right, the other thing we can say here is you can see it says return super.total. And you'll learn about this more later, but this is just saying I'm going to go back to the pizza order and return whatever this thing did. It's going to call this method, it's going to get 5, and then down here it's going to return $5. So that's not a bad thing, and I could actually utilize that in the pepperoni pizza to not have to remember this $5 price. If I changed the price from $5 to $6, or I gave a sale from $5 to $4, I'd have to change that number here, and I'd have to change that number here, unless I use super.getTotal, in which case I can only change it. I can afford to change it one spot. All right, so that's a little bit what's going on here. So let's do the logic of region of fish. So we can say if region, so let's do Europe, EUROPE dot equals. Now I'm doing it this way specifically because it allows us to check for null at the same time. If region of fish isn't set or isn't set properly, it would get a null pointer exception if I said region of fish dot equals Europe. But if I use Europe dot equals, then what that means is I know this thing exists and I won't get a null pointer exception. So if you ever see stuff backwards like this, that's why they do that. So region of fish. So let's just say we have a price instead of here. We'll call it double fish cost. All right. Is equal to, let's say the base cost of that is $3. And so if it's a European fish, then that's a fancier fish than, let's say, the American fish that you'd get from an anchovy. I don't know if they have anchovies in the United States, but maybe they do. So then we'll say the fish cost is equal to $5. Else if Asia dot equals region of fish, and then we'll say in this case the fish cost is equal to $4. Let's say it's Asia's more fish and they'll get it to us. Otherwise we do the regular total plus the fish cost. So our logic here is by getting an anchovy pizza, we're going to put some fish on there, and if you get plain old American or South American fish, it's $3. If I go and get my fish from Asia, it's a $5 surcharge, and Europe, it's a $5 surcharge. Asia's a $4 surcharge, in which case I return that. Now, what I can't forget here is my region of fish isn't going to be set unless I give it a way to be set, so I need to provide getters and setters. And again, the easy way to do that, I'll use the fancier technique. I'm going to hold down Alt, Shift, and hit S, which if you remember, I can also do right-click, source, right here, Alt, Shift, S. That's the same thing. Oops. So Alt, Shift, S, and then I can say generate getters and setters for my region of fish, and boom. Now I have my class to do that. I could do it one more time, the same process for veggie. Just quickly, I would have some sort of attribute here. Maybe the number of veggie types that's on it. And then we would say Alt-Shift-S, override implement methods here. I would be overriding the total. And while I'm at it, I'll do Alt-Shift-S. We'll do getters and setters for the veggie types. And let's say the total here is the super total, $5 plus 75 cents times the veggie types. So each vegetable costs 75 cents or something like that. So that would be the way I calculate the cost of this pizza. All right, so now going back to my picture, I have 3 different subclasses of pizza order. So technically I have 4 different pizzas you can get, cheese plus 3 others. And we need to integrate this into our application. So we'll do that next. But what I'd like you to do is try and get this code to compile. See if you can get 3 different subclasses, either exactly the same 3 pizza ones if you want to practice, or whatever you want to do for your application. So do that now, and when you have that up and ready, then we'll try and work on integrating it.